Hi class, so today we are going to be taking a look at adding and subtracting polynomials. So we're taking the same concepts that we were looking at last week, but we're expanding it into something bigger. So instead of just looking at one little piece plus one little piece, we're now going to be looking at what happens when there's a lot more pieces going on. And the good news is that our rules are still the same. Okay, our rule still says that when we add or subtract with polynomials, we are going to add or subtract the big number in front, which we call the coefficient. And we are going to keep the exponent the same. The key to remember is that we cannot add two things if they do not have matching exponents to start with. So we can only add if they already have matching exponents. So today when we look, we're going to have terms that don't necessarily have matching exponents, and we're going to have to pair up the pieces that are alike. So the easiest way to see an adding or subtracting problem with polynomials is when they're already stacked for us. So if we have something like 6x to the third plus 5x squared minus 4x. Now, keeping in mind, none of these pieces can be combined because they don't have matching exponents. But we're going to add that to another polynomial, something that has many terms, maybe like 5x to the third minus 7x squared minus 2x. And just like when we add with multi-digit numbers, like 117 plus 248, right, we add straight down. When we're stacked like that, this is exactly what we are going to do here as well. So we're just going to take and we're going to add down each column, right? This is an exponent of 3 and this is an exponent of 3. So we're going to get an answer out of this with an exponent of 3. And then all we need to do is do 6 plus 5. So even if you say you're really bad with your basic addition and subtraction, just pick up your calculator and do 6 plus 5, and then keep that exponent the same. And then we're going to do the same thing here, right? This is a 2, this is a 2, so we know we're going to have an x squared. And then we'll use our calculator to do a 5 plus negative 7. Okay, and that will give us a negative 2. And then same thing here, this is an x, so our final piece will be an x. And in our calculators, we'll do a negative 4 plus a negative 2, which will give us a negative 6x. And so our final answer will be x to the third minus 2x squared minus 6x. We cannot do anything any further. Nothing else can be added or subtracted because we don't have matching exponents. And so that's just our answer and we're done. Now, we have to be a little bit more careful when we have subtraction. So if we have something like 7w to the 5th plus 8w to the 3rd minus 2w squared, and we want to subtract, maybe something like 5w to the 5th minus 2w to the 3rd plus 5w squared. It's not that we can't do it exactly like this problem we did up here. The problem comes into play with this negative, and we have to be really, really careful with it because we don't always have matching pieces. Okay, when they're stacked, we will, but in the long run, we won't always. And the easiest way to deal with a subtraction problem is to not actually subtract at all. Instead, what we're going to do is add the opposite, right? Just like we've learned that if we have something like 6 minus negative 4, those two negatives make a positive because we can add the opposite. We're going to do that same thing here. So we're going to change this subtraction sign to addition. And then we want to change the sign of everything after it. Nothing before it, only the stuff after it. So that means only this bottom row. So because this was a positive 5, it becomes a negative. Because this was a negative 2, it becomes a positive. And because it was a positive 5, it becomes a negative. And then once we do that, we have way less issues to worry about with our negatives, and we can do exactly what we did up here and add. So we'll say a 7 plus a negative 5 is 2. Again, our label stays the same. 8 plus 2 is positive 10. Our label stays the same. And a negative 2 and a negative 5 gives us a negative 7. And our label stays the same. Now, we also want to be able to deal with these when they aren't stacked. So what happens when they're written side by side? So what happens if I have something like 4x squared plus 8x minus 3, and we're going to subtract 7x squared minus 3x minus 1. Now, you could decide in this case to rewrite it underneath here. Okay, but again, they won't always stack nice and perfectly, so we want to make sure we can deal with it either way. So the first thing, hopefully, that we recognize is that this is a subtraction problem. And we said if we saw subtraction, we would want to change it to adding the opposite. So I'm going to change this subtraction sign to addition, and then change the sign of everything after it. So the positive 7 becomes negative, my negative 3 becomes positive, and my negative 1 becomes positive. And so now I'm going to just combine like terms. So I'm going to go through and I'm going to look for anything that is matching. So if I look here, I have a 4x squared and a negative 7x squared, right? Those match because they both have exponents of 2. So 4 and a negative 7. So again, in your calculator, you could do 4 plus negative 7. That's going to give us a negative 3, and the exponent stays the same. Okay, then I have an 8 plus 3. Okay, so when I add those, that gives us 11, and the label stays the same. Okay, sometimes it helps to sort of write, underline, check off the ones you've used. And we have a negative 3 and a positive 1. So a negative 3 and a positive 1 gives us a negative 2. And that's our answer there. Okay, so let's look at one more problem. (6x squared minus 5x plus 11x plus 5 minus 2x squared minus 6. Okay, so in this one, we have more pieces, right? We now have 1, 2, 3 pieces being added, and we definitely can't stack them because they aren't all matching in turns. So instead, it's going to be our job to just find the pieces that can go together. Okay, so we see that over here we have subtraction. Whenever we have subtraction, we want to change that to addition. And we're going to change the sign of anything after it. So the positive 2 is going to become negative, and the negative 6 is going to become positive. Okay, so now that I have everything as addition, I'm just going to find pieces that are the same. So this 6 has an exponent of 2. So I want to look and see if anything else has an exponent of 2. Yep, and over here, right, I have another exponent of 2. So those two pieces can be combined. So a 6 plus a negative 2 is going to give me a 4, and the x squared stays the same. Okay, then I'm going to move and see what else I have. Okay, well, this is an x. So do I have anything else that's an x? Yep, I have an x here. Okay, so I have a negative 5 plus 11, right? Negative 5x plus 11. If I do negative 5 plus 11, I get a positive 6, and my label of x stays the same. Okay, so I've used this, I've used this, I've used this. Okay, then I have this piece here. So that doesn't have a variable. So I'm looking to see if there's anything else that doesn't have a variable, and there is over here. So I want a positive 5 plus 6, which gives me 11. I've used every single piece, So there's my final answer.